I mean, up till now, so I'm starting the lecture, okay, officially. So I'm going to tell you regarding that. I mean, in the previous lectures, what we have covered, we are just encrypting our data by using public key cryptography, by using symmetric cryptography, and by using their different I mean algorithms or different modes. We are going to encrypt them by using certain sort of key, right? As we have discussed earlier, the key has a very important role in any type of encryption. I mean, either it is a symmetric encryption or it's a asymmetric encryption or whatsoever it could be, we need to use a key, right? So today we are going to, and what type of services we are getting by implementing this type of security? We are getting, I mean to say that confidentiality, we are getting authentication, we are getting non-repudiation, and all these services, right? When we are talking about asymmetric and symmetric cryptography, and there are different techniques or modes that we have discussed earlier. Now today we are just going to discuss regarding another type of service that we are getting throughout the communication of a message, that is called as your integrity, message integrity. I mean, you people are very much familiar with this particular term, that your information must not be modified on the go, right? If your information is flowing over a network, it must not be modified by any unauthorized person. That's what we have learned so far regarding the integrity. Now how we are going to achieve this? Now let's start with, now slide number 2, message integrity, parity bits and cyclic redundancy check, that is called as CRC, functions have been used in protocols to detect modifications in streams of bits as they are passed from one computer to another, but they can usually detect only unintentional modifications, right? Unintentional modification can happen if spike occurs in the power supply, if there is an interference or attenuation on a wire, or if some other type of physical condition happens that causes the corruption of bits as they travel from one destination to other. Now see, I mean, you people are well aware about the term parity bit and cyclic redundancy check, as we have discussed in computer networks also. I mean, when your data is being traveling from source to a destination, at the source some sort of calculations are being made, right? And the same calculations are being made when the data is being received at the receiver's end. Now when these calculations are going to be compared at the receiver's end, if these both values are the same, I mean that we have calculated so far at the receiver's end as well as at the sender's end, this means that your data has not been modified, I mean to say that completely, right? But if there is any type of I mean not miscalculation, but if there is some sort of alteration, I mean I mean if there is no comparison is being made between the two values are different, this means that there is some alteration has been made or some intrusion has been made during the transmission of the data, right? So this type of I mean to say that mechanism is called as cyclic redundancy check, that has been applied at the senders, at the receivers, and during the transmission of the message, right? So that we have already discussed in our computer networks class in our last semester, and this is going to ensure the integrity of the message. I mean, no any modification has been made by some sort of I mean unauthorized person. But the important thing to understand, this type of check is only going to detect type of modifications which are being made during the transmission. I mean, when your data is being traveling over a wire, and if there is any attenuation, any spike of voltage occurs, and some bits are going to be from 0 to 1 or 1 to 0, such type of modifications or alterations are being detected by using your cyclic redundancy check, right? There is no any intentional modifications are being, I mean to say that, monitored by such type of mechanism, right? So how we are going to manage such type of modifications, I mean to say that intentional modification, how we are going to cope with, we have to learn in terms of message integrity, right? So parity bits cannot identify whether a message was captured by an intruder altered and then sent on to the intended destinations. So the intruder can just recalculate a new parity value that include his changes and the receiver would never know the difference. For this type of production, hash algorithms are required to successfully detect intentional and unintentional unauthorized modification of true data. We will now dive into the hash algorithms and their characteristics. Now see, parity bits are being used in order to confirm whether your data is being altered or not, and we don't know that who have altered that particular data. I mean, whether it was an intruder, whether he's the right person or not, or like that, right? So the intruder can just recalculate a new parity value that include his changes, and the receiver would never know the difference. The same man in the middle attack. I mean, if in between some intruder is going to get that information, recalculate the parity and send that modified information to the receiver. Now receiver must not know that this information is coming from the legitimate person or some type of intruder. In order to manage this type of problem, the information security gave you an idea of hashing algorithms or hash, and most of the time you people have asked earlier regarding is there hashing or like that. I mean, you people have heard from somewhere in your daily life कि hash होते हैं, कैसे calculate होते हैं, and I have told you that when the time will come, I will let you know that what is the implementation of hashing algorithms. And there is a difference between hashing and the encryption, right? Over in this particular scenario, we are not doing any type of encryption. ये चीज आपको क्लियर होनी चाहिए यहाँ पे, ठीक है? We are not applying any type of encryption, but actually we are going to achieve the integrity of the information. The information must not be modified. How we are going to manage this type of situation, that we are going to manage with the help of hashing algorithm. अब ये क्या होते हैं? Let's dive into this. The one-way hash. I mean, you people have very much familiar with the term one-way function, and I have told you that one-way function is being applied in the forward direction as well as in the backward direction, right? For all type of symmetric algorithms we have discussed regarding Ilgamal, then we have knapsack and all these, and at the end of, at the back end of each function, there is a mathematical challenge that is going to be performed, right? So when we are talking about a one-way hash, now this is not a one-way function, this is a one-way hash. In this particular scenario, what is going to be happen? Your only forward direction mechanism is going to be calculated, right? How? Let me read it for you. A one-way hash is a function that takes a variable length string and a message and produced a fixed length value called a hash value. अब इसमें क्या होता है? It's very important to understand. आपके पास एक hash value calculate होती है. Now how it is going to be calculated? A one-way hash is a function that takes a variable length string. I mean, it is going to take any type of value and a message and the original message and produce a fixed value or fixed length called a hash value. This is going to calculate a value based on certain sort of text, and that value is called as hash value. For example, if Ahmed wants to send a message to Bilal, and he wants to ensure that the message must not get altered in an unauthorized fashion while it is being transmitted, he would calculate a hash value for the message and append it to the message itself. अब जैसे वन वे हैश में क्या होता, सॉरी वन वे फंक्शन में क्या होता था, वी आर गोइंग टू कैलकुलेट one way function में we are going to calculate certain values at the sender's end by using certain symmetric keys, but here we don't have to use any type of key. अब इसमें क्या होगा कि we have a one way hash function, I mean some sort of, you may call it as a software or any type of algorithm, or it might be any type of function, right? Your message would be passed through that particular one way function, and that one way function that is called as your one way hash function has to generate a fixed length value, right, at the sender's end, and that fixed length value is called as hash value, right? And that hash value is being appended with the original message, and that information would be sent to the receiver, right? When Bilal receives the message, he performs the same hashing function Ahmed used and then compares his result with the hash value sent with the message. Now what Bilal has to do? Bilal has received the message. I mean, in message what he has received the hash value as well as the original message. Now he will not touch that hash value. He will collect that original message pass through that hash function that has been performed at the sender's end and would calculate a new hash value, right? Now that hash value would be compared with the hash value that has been coming from the Ahmed, right? If these two values are same, this means that your message has not been modified. There is no any modification has been made inside the data. But if there is some alteration in the value or there is some uncompatibility between the values, this means that your data has been modified on the way, right? So if the two values are the same, Bilal can be sure the message was not altered during transmission. If the two values are different, Bilal knows that the message was altered either intentionally or unintentionally, and he discards the message, right? So this is the basic idea of a one-way hash. So the one-way hash, the hashing algorithm is not a secret. It is publicly known. The secrecy of the one-way hashing function is its one-wayness. The function is run in only one direction and not the other direction. This is different from the one-way function used in public key cryptography, in which security is provided based on the fact that without knowing a trapdoor, it is very hard to perform the one-way function backward on a message and come up with a readable plain text. Now see, hashing algorithm is not a secret algorithm. It's public to everyone. And how the secrecy comes to a one-way hash? By the one-wayness. I mean, how the function is going to be performed in the forward direction that takes the secrecy inside a algorithm. So this function runs in only one direction. It might not be working in the backward direction like your one-way functions, right? So this is a different from the one-way function used in public key cryptography, in which the security is provided based on the fact that without knowing a trapdoor, it is very hard to perform the one-way function backward on a message and come up with readable plain text. What we have discussed in public key cryptography, until we are not familiar with the trapdoor, we cannot perform the same function backward in order to get the plain text. I mean to say, right? So trapdoor is very important, but in this particular situation, we don't need any trapdoor. We don't need any function that needs to be performed in the backward direction. So this always been performed in the single direction, right? So the hashing one-way function takes place without the use of any key. Let's take a look at an example. Now see, in one-way hash there is no concept of a key. जैसे हमारे पास previous concepts में use हो रहा था ना कि we need to have a key, but here we don't have a key, right? Now example of a one-way hash: if Irfan writes a message, calculates a message digest, appends the digest onto the message and send it on to Furqan, Khalid can intercept this message, alter Irfan's message, recalculate another message digest, append it to the message and send it to Furqan. When Furqan receives it, he verifies the message digest but never knows the message was actually altered by Khalid. Furqan thinks the message came straight from Irfan and it was never modified. Because the two message digest values are the same, if Irfan wanted more protection than this, he would need to use message authentication code. So what is that? This is a very simple man in the middle attack that is possible in one-way hash also, right? I mean, there is an Irfan and there is a Khalid, right? Sorry, Irfan and Furqan. Irfan and Furqan used to communicate by using one-way hash, right? One-way hash is being calculated at the Irfan side. It is being appended with the message and sent it to Furqan. In between, there is some interception has been made by the Khalid. He captured the message that is coming from Irfan. He modified the information and recalculate the, I mean to say that one-way hash at his end. And that information he sent to Irfan, right? Sorry, Furqan. Now, Furqan, when received that information, might not know that this information is either coming from Furqan or it is coming, from Khalid or it is coming from Irfan. So based on this information, there is a possibility that there is a chances of man in the middle attack in this particular situation. So in order to overcome this particular problem, we do have another type of version of hash function that is called as your MAC, message authentication code, right? Now, how does it works? A MAC function is an authentication scheme derived by applying a secret key to a message in some form. This does not mean a symmetric key is used to encrypt the message though. You should be aware of two basic type of MACs, a hash MAC and CBC-MAC. Now see, in this particular scenario, we are using a key, but that key will not be used for an encryption purpose. ठीक है जी, ये बड़ी इंपॉर्टेंट चीज अंडरस्टैंड करने के लिए यहाँ पे कि की विल नॉट बी यूज फॉर द इंक्रिप्शन पर्पस, रादर it is being mixed with your data and it is going to create some sort of randomness inside your information, right? So key would not be used. Ultimately we will be using a symmetric key, but that key will be used as a simple set of bits, right? It might not be using as a encryption function, or it will not be performing any type of encryption at the senders as well as at the receiver's end, right? So in this particular MAC function, what we are going to do, we are going to provide a secret key that is called as a symmetric secret key that is being added in order to make your information more secure, right? So there are two types of MAC. One is called as your HMAC, another one is called as your CBC-MAC, right? Now what the HMAC is, in the previous example, now we have to take the same example in which there is a possibility of man in the middle attack. In the previous example, if Irfan were to use an HMAC function instead of just a plain hashing algorithm, a symmetric key would be concatenated with his message. The result of this process would be put through a hashing algorithm and the result would be a MAC value. This MAC value is then appended to this message and sent to Furqan. If Khalid were to intercept this message and modify it, he would not have the necessary symmetric key to create the MAC value that Furqan will attempt to generate. Now see, very simple, the same concept, that how we are going to overcome man in the middle attack. I mean, if Irfan is sending some information by using an HMAC function instead of just a plain hashing algorithm, right? What he has to do, he has to add a symmetric key would be concatenated with his message, the original message plus the symmetric key. Now that both of the key and your message would be passed through an HMAC function. The result of this process would be put through a hashing algorithm and the result would be a MAC value. Now the result that is being generated from that hashing algorithm would be a MAC value, right? Now that MAC value would be appended with the original message and sent to Furqan. If in between Khalid is going to intercept that particular message, he can generate his own hash value, but he does not have the key that was only been available with the Irfan as well as with the Furqan, right? So Khalid does not have the availability of that key, that symmetric key that is being used at the sender's at the receiver's end. Now when he used to make any type of hash from the existing value, it might not be the same between the sender and the receiver, and receiver definitely knows that this message is not coming from the legitimate user, I mean Irfan, but this is coming from some other person, right? So through this mechanism, we are going to overcome the problem of man in the middle attack in our hashing functions, right? So terminology, the idea of hashing function is very simple. You run a message through a hashing algorithm, which in turn generate a hashing value. A hashing value can also be called as a message digest or a fingerprint. Acha ji, I mean, you must be clear regarding certain terminologies that we already have discussed regarding the security, right? Now, in this particular term, I mean message integrity, if somebody is going to say that some message and the secret key is passing through a hashing algorithm and the resulting value that is being generated, that would be a converted value. Now that converted value is called as your hashing value. You may call it as a message digest or a fingerprint. अब अगर कहीं पे आपको लगता है कि जी message digest word use हो रहा है या fingerprinting word use हो रहा है, so this means that this value is being generated through certain hashing algorithm, right? So you must not be confused what might be a message digest or what might be a fingerprint value or like that, right? So now the whole procedure is being explained through the help of diagram. This is a hashing. This is a simple hashing. This is not an HMAC, make sure. This is the simple hashing. You have an hashing algorithm on the left hand side. You have the message. When these both are being combined, and they are being I mean to say that passed through a hashing algorithm. That message is passed through an hashing algorithm, and the resulting value that we are getting, that would be a message digest, or you may call it as hashing value, right? Now that message digest would be I mean to say that appended with the original message and sent to the receiver. At the receiver's end, that message, only message, make sure it must be clear to all of you, आपके पास message digest किसका है? Of the sender. That message has to be taken out. That message is passed through a hashing algorithm. A new message digest is being calculated. Now that message digest is being compared with the message digest that has been coming from the sender. If both values are same, this means that your data is not being altered. If they are different, this means that your data is being altered. अब ये पूरे का पूरा ना वही steps लिखे हुए हैं, इसको आप पढ़ लीजिएगा. From 1 to 7, the sender puts a message through a hashing function. A message digest value is generated. The message digest is appended to the message. The sender sends the message to the receiver. The receiver puts a message through a hashing function. The receiver generates his own message digest values. The receiver compares the two message digest values. If they are the same, the message has not been altered. Right? Now these are the all are the steps that are being I mean to say that I have already told you with the help of diagram. Right? Now this diagram is going to give you an idea of HMAC. Right? हम यहाँ पे हमारे पास क्या है? HMAC का कॉन्सेप्ट है. आपके पास मैसेज, आपके पास सीक्रेट की, दोनों ऐड हो रहे हैं. ऐड होने के बाद they are being passed through a hashing algorithm, right? And you would be getting a message digest value, or you may call it as a MAC value, right? That MAC value would be added with the original message. इस वाले मैसेज के साथ अटैच होगा, ठीक है? And then that value would be sent to the destination, right? At the destination, that message and the secret key that is available with the receiver, they are being added and passed through a hashing algorithm, and another MAC value is being generated at the receiver's end also. Now that MAC value and the MAC value that is coming from the sender, they both are compared. If they are same, your value is not been altered. If they are different, your value is being altered, right? ये सारे steps हैं, I mean from 1 to 8, the same that I have explained you in the diagram. You need to, I mean to say that, read it by yourself. Now slide number 16, concatenation. Now when we say that the message is concatenated with a symmetric key, we don't mean a symmetric key is used to encrypt the message. The message is not encrypted in an HMAC function, so there is no confidentiality is being provided, right? So this is very much clear. Your symmetric key and your message are just appended with each other. They are not been encrypted. आपका जो message है वो symmetric key से encrypt नहीं हो रहा, बल्कि symmetric key और आपका जो message है, they are combined and passed through a hashing function, and the resulting value that is being generated, that is called as your message digest, that is being appended with the original message and sent to the receiver, right? So make sure when encryption is not being performed at the HMAC function, so this means that confidentiality is not going to be achieved, right? So think about throwing a message in a bowl and then throwing a symmetric key in the same bowl. If you dump the contents of the bowl into a hashing algorithm, the result will be a MAC value. Now see, this is just an analogy that they have created for the above scenario. I mean, what he's telling that let's take a bowl, and inside that bowl you have to throw a message that needs to be transmitted, and you need to put a symmetric key inside that bowl. You have to put the same key inside the bowl, and then you have to pass this bowl through a hashing algorithm, right? And the resulting value that is generated from that particular hashing algorithm would be your MAC value, right? So this is just an analogy of the concatenation, right? Then you have HMAC and symmetric key. This type of technology requires the sender and receiver to have the same symmetric key. So the HMAC function does not involve getting the symmetric key to the destination securely. That would have to happen through one of the other technologies we have discussed earlier, like Diffie-Hellman and key management or RSA key exchange. Now see, HMAC का ये फंक्शन नहीं है कि वो सिक्योर की डिस्ट्रीब्यूशन करे. It's just for the purpose of generating a hash at both the ends. I mean at the sender's end as well as at the receiver's end. Now the key distribution, like symmetric key, we know that the key distribution is a big issue. So the key distribution is the responsibility of some other services like your Diffie-Hellman key agreement protocol and RSA is your key exchange protocol. So by adding this functionality, we are going to have such type of scenario inside this particular function, right? So your HMAC is just going to generate a hash value, but your key exchanges like symmetric key at the senders as well as at the receiver is going to be managed by some symmetric and asymmetric algorithm like your Diffie-Hellman and your RSA, right? So again, we have another type of, I mean to say that algorithm hashing that is called as your CBC-MAC. If a CBC-MAC is being used, cipher blockchain MAC, right, is being used, the message is encrypted with a symmetric block cipher in a CBC mode, and the output of the final block of ciphertext is used as the MAC. Now this is a bit tricky, but not that much tricky, right? You just need to understand the concept. The sender does not send the encrypted version of the message, but instead sends the plain text version and the MAC attached to the message. The receiver receives the plain text message and encrypts it with the same symmetric block cipher in CBC mode and calculates an independent MAC value. The receiver compares the new MAC value with the MAC value sent with the message. This method does not use a hashing algorithm as does like an HMAC, right? अब इसमें आपके पास क्या होता है? Now, if you people are well aware about the cipher blockchain, उसमें क्या होता था? आपके पास IV initialization vector यूज होता था, आपके पास keys यूज होती थी, which are being combined with the ciphertext, and you would be generating. I mean, the output of the first block is coming to the input of the input as an input to the second block, and that ciphertext is combined with the plain text and then passed through encryption, and encryption is being performed, and the resulting ciphertext would be going to the third block as an input. Now this mechanism is being performed in cipher blockchain mode, right? In this particular scenario, what happens? The same applies over here. The message is encrypted with a symmetric block cipher in CBC mode. आपका जो message, जो original message आप hashing के through आप भेजना चाहते हैं, that is being encrypted with a symmetric block cipher in CBC mode, and the output of the final block of ciphertext is used as a MAC. अच्छा जी, इसमें हमने use फिर भी MAC ही करना है, लेकिन अब इसमें कौन सा MAC use होगा? आपने पूरा ब्लॉक साइफर है, ये आपके पास इनपुट आउटपुट प्रोसेस होता हुआ जो फाइनल ब्लॉक का आउटपुट होगा, दैट वुड बी काउंटेड एज द मैक वैल्यू फॉर दैट पर्टिकुलर सिनेरियो। ठीक है जी, आपने एक साइड के ऊपर मैक वैल्यू जनरेट की बाय यूजिंग सीबीसी मैक। ठीक है जी, आपके पास थ्रू दैट सीबीसी मैक आपकी इनपुट सेकंड ब्लॉक में गई, वहां से साइफर टेक्स्ट जनरेट हुआ, साइफर टेक्स्ट फिर थर्ड ब्लॉक में गया, वहां से आपके पास फिर एक साइफर टेक्स्ट जनरेट हुआ, देन साइफर टेक्स्ट वुड बी गोइंग टू द फोर्थ ब्लॉक, इट कंबाइंड विद द प्लेन टेक्स्ट, एंड देन यू हैव another साइफर टेक्स्ट, एंड फाइनली द फाइनल ब्लॉक आउटपुट जो आपके पास साइफर टेक्स्ट होगा, दैट वुड बी कॉल्ड एज यूर मैक वैल्यू, राइट? नाउ व्हाट हैपेंस, दैट मैक वैल्यू would be combined with the original message जिसको हम भेजना चाह रहे हैं। अभी तक हमने मैसेज भेजा नहीं है, हमने just MAC कैलकुलेट किया है by using a CBC MAC, right? Now that MAC value is being appended with the original message, right? And that original message and that MAC value would be sent to the receiver, right? Now when receiver would receive that particular message, now the same functionality, the same mechanism is being applied at the receiver's end also. Now at the receiver, what is going to be happen? आपका मैसेज अलग होगा, ठीक है, उस मैसेज के ऊपर सीबीसी मैक वहां में भी कैलकुलेट होगा। ठीक है, अब द सेम मैसेज एंड यूर आई मीन टू से दैट सीबीसी मैक इज बीइंग कैलकुलेटेड एंड इट इज गोइंग टू फॉर्म एन अदर मैक वैल्यू। द लास्ट ब्लॉक जो आपके पास कैलकुलेट होगा वो मैक आप उठाएंगे, दैट मैक एंड द मैक दैट इज कमिंग फ्रॉम द सेंडर, राइट? दे बोथ आर कंपेयर्ड. If they are same, this means that your value is not being altered, and if they are different, this means that your value is being altered, right? So this is how your CBC MAC is going to be executed. The use of the symmetric key ensures that the only person who can verify the integrity of the message is the person who has a copy of this key. So no one else can verify the data's integrity, and if someone were to make a change to the data, he could not generate the MAC value, HMAC or CBC-MAC. The receiver would be looking for any modification would be detected by the receiver. Now the same thing, I mean in the both scenarios, अगर हम CBC-MAC की बात कर लें या HMAC की बात कर लें, you have the concept of a symmetric key. In the first scenario, your symmetric key is just being used as for the randomization process, right? And only that person can decrypt the information, or I mean not decrypt, we can say that, but calculate the hash value who might have that particular key at the receiver's end, right? In between, if some intruder is going to get that information, he cannot decrypt that, cannot calculate the hash value against that particular data, right? The same applies to the CBC-MAC. CBC-MAC is going to apply the block symmetric function at the sender's end as well as at the receiver's end. Now, sender and receiver must have the symmetric key also. Now, जिस symmetric key से आपके पास encryption perform होगी, that must be same at both the ends. Now, the person who only have that particular symmetric key can perform this particular hashing CBC-MAC, right? So now the receiver knows that the message came from the system that has the other copy of the same symmetric key. So MAC provides a form of authentication. It provides data origin authentication, sometimes referred to as a system authentication. This is different from user authentication, which would require the use of a private key. Now see, CBC-MAC जो है ना आपका, this is going to provide you another type of service that is called as authenticity service at some level, we may say that, right? How? Because when the information is coming, when the information is being received at the receiver's end, receiver knows that this information is only coming from the person or the system which might have the symmetric key. Nobody else can send me this information, right? So this is going to ensure the authenticity of the information, but this type of authenticity is called as your data origin authentication or your system authentication. This is not related to the user level authentication. User level authentication हम कैसे achieve करते हैं? User level authentication हम कैसे achieve करते हैं? We are going to achieve with the help of public private key pair, right? But in this particular scenario, what we have, we are going to achieve system level authentication. We may say that this message is coming from some legitimate system, right? So this is how we are going to achieve system level authentication by using CBC-MAC. So a private key is bound to an individual, a symmetric key is not. MAC authentication provides the weakest form of authentication because it is not bound to a user, just to a computer or a device. Now see the same thing, the private key is going to provide you the highest level of authentication, like the message is coming from which person, because the private key is only being with the person who has generated that particular key, right? So the MAC authentication provides the weakest level of authentication because it is not bounded to a user. It is just a computer or a device, right? So this is how we are going to achieve, or we are going to learn regarding the CBC-MAC. So that's all from my side.